I still find it astonishing that something as ordinary as a second is not a simple thing at all. It isn't something we can hold. It isn't something we can see directly. It isn't even something that exists independently. A second is something we define, and right now, humanity is redefining it again. Not because our old clocks stopped working, but because our ability to measure reality itself is evolving. From shadows to atoms, the long journey of timekeeping. For most of human history, measuring time meant watching the sky. We tracked shadows moving across sundials. We listened to pendulums swing. We counted mechanical oscillations. Later, quartz crystals brought unprecedented precision. Then came atomic clocks, which transformed everything. Cesium atomic clocks measure time using the vibrations of cesium atoms, incredibly stable processes that provide extraordinary accuracy. These clocks became the global standard for defining the second. They are so precise that they would drift by only about 1 second over tens of millions of years. But even that level of precision is no longer enough for modern science. Enter the optical lattice clock, counting time with light. The newest generation of timekeeping devices represents a massive leap forward. Optical lattice clocks measure atomic vibrations using visible light frequencies instead of microwaves. This change is revolutionary. Light waves oscillate far faster than microwave signals, and faster oscillations mean finer measurement resolution. The result is almost unimaginable. Modern optical lattice clocks are accurate enough to lose or gain just 1 second over tens of billions of years, longer than the age of the universe itself. This is not merely an incremental improvement. It is a transformation in humanity's ability to measure reality. The global timekeeping network, defining time. Together time today is not determined by a single clock. It is defined by a global network of the world's most accurate devices. These clocks collectively establish what we call coordinated universal time. When a new ultra-precise clock joins this network, it does more than contribute data. It helps redefine what time means for the entire planet. Recently, China's optical lattice clock technology reached a milestone by contributing to international timekeeping standards. This marks a new phase in a quiet but profound global race. Not a race for territory, but a race to measure reality with greater precision than ever before. Why ultra-precise time matters. At first glance, measuring time to billion-year accuracy may seem unnecessary, but ultra-precision clocks unlock extraordinary capabilities. Because gravity affects how time passes, extremely accurate clocks can detect tiny differences in gravitational strength. This allows clocks to act as sensors. They can measure height, differences as small as a few centimeters, by detecting variations in time flow. This capability could transform Earth science. It could help monitor tectonic activity, track volcanic changes, map underground structures, detect subtle shifts in Earth's crust. In space science, these clocks can test fundamental physical theories with unprecedented sensitivity. They may even detect minute changes in the constants of nature. Toward redefining, the second optical lattice clocks are now so accurate that scientists are considering redefining the official SI second based on their measurements. This would be the first major change in time standards since the adoption of cesium atomic clocks. Such a redefinition would not simply update a technical measurement. It would reflect a deeper shift, a shift in how precisely humanity can describe the universe. The hidden truth about clocks. There is a profound realization at the heart of this technological race. Clocks do not measure time itself. They measure change. They count vibrations. They track transitions. They register motion. Each improvement in timekeeping reveals a deeper truth. Time is not directly observable. It is inferred from patterns of change. The more precise our clocks become, the more deeply we probe the structure of reality. A Perspective Through Humans Actuators of Time by J.J. Simon. This evolution in timekeeping connects directly to a core insight explored in Humans Actuators of Time. Humans do not passively experience time. We actively construct systems to interpret it. We build instruments that transform invisible processes into measurable intervals. We define units that allow collective synchronization. In doing so, we participate in shaping how time is understood. Each new clock is not merely a device, it is a new lens through which reality becomes more clearly structured. Measuring time is measuring reality. As clocks become more precise, their role expands. They are no longer just tools for scheduling, they are instruments of discovery. They detect space-time curvature. They measure gravitational differences. They reveal subtle physical processes. They test the foundations of physics itself. In this sense, the race to build better clocks is not just about timekeeping. It is about understanding reality at its deepest level, the deeper meaning of the timekeeping race. Every leap in time measurement has reshaped how humanity sees the universe. Sundials connected us to celestial motion. Mechanical clocks enabled industrial civilization. Atomic clocks made global communication and navigation possible. Optical lattice clocks now push us toward a new frontier. They bring us closer to the fundamental structure of space-time. They allow us to measure reality with unprecedented precision. They blur the boundary between timekeeping and physics. A closing reflection. It is remarkable that something so familiar, time, remains one of the deepest mysteries in existence. We cannot see it directly. We cannot touch it. We can only measure change and infer its structure. And yet, with each new generation of clocks, we come closer to understanding its nature. In that pursuit lies one of humanity's most profound achievements, turning the invisible flow of existence into something measurable. And in doing so, revealing that time is not merely something we track, it is something we continually redefine.